NASA's annual budget is significantly smaller than that of the US military, so they tend to be frugal with their spending. Every taxpayer dollar counts, so why would they spend $325 million just to crash a spacecraft into an asteroid? Most crashes are, well, accidents, but this one was intentional. In fact, the collision was the grand finale of the DART mission. DART stands for Double Asteroid Redirection Test. If you Google DART mission, you'll see a quirky little animation. The DART spacecraft flies in from the left, crashes on the right side of the screen, and then everything tilts about 15 to 20 degrees. That's Google's way of celebrating the mission's success. A pretty flashy celebration, right? The target for the DART spacecraft was a binary asteroid system called Didymos, which means twin in Greek. This system is made up of two bodies, Didymos, the larger one, measuring about 0.47 miles in diameter, and its smaller moon, Dimorphos, about 492 feet wide, which orbits the bigger one. Asteroids are small celestial bodies that move incredibly fast. Even relatively small ones, if they enter our atmosphere and hit the ground, can release energy equivalent to thousands of Hiroshima-level bombs. So the big question is, do we currently have the technology to deflect an asteroid that might threaten our existence? The DART mission was born in 2015 with that exact goal: to run the first planetary-scale experiment to test whether we could deflect a celestial object using today's technology. The ultimate objective was to develop a method to one day redirect an asteroid that poses a real threat to Earth. And Didymos was the perfect candidate for this first planetary defense experiment. It's not on a collision course with Earth and doesn't pose any real danger, but its characteristics made it ideal to test whether intentionally crashing a spacecraft into it could alter its path. We've sent spacecraft into space before. We've gone to the moon, landed on Mars, and even brought back samples from an asteroid. Voyager 1, launched back in the 1970s, is already heading toward interstellar space. But up until now, we've only been passive observers of the cosmos. We've never actually tried to change the behavior of a celestial body. There are thousands of asteroids and comets in our solar system. Many cross Earth's orbit and pose real threats. These are called NEOs, near-Earth objects. NEOs can be small or very large. If they hit Earth, the damage depends on their size and material. They travel very fast, and when they enter the atmosphere, they can explode. Smaller ones break apart in the air, but can still cause heat or strong shock waves. Medium-sized ones can reach the ground and create a big crater. Very large ones could cause disasters like earthquakes and explosions. Although it's rare, this happens every many millions of years. Didymos is only 0.47 miles wide, but if something like that hit Earth, it could cause destruction on the scale of an entire state. That's why being able to deflect an asteroid with that kind of destructive power would be a turning point in space technology, and potentially a way to prevent a future catastrophe. September 27th, 2022 was the key date. That morning, we would find out if we had the tech to protect ourselves. After a journey of nearly 10 months, the DART spacecraft finally slammed into Dimorphos. Around 20 observatories around the world confirmed the impact. NASA even streamed the moment live.
All right. We got it? Waiting.
And we have impact. A triumph for humanity in the name of planetary defense.
Woo. Fantastic.
Since the footage came from DART's onboard camera, it didn't capture the actual collision. So NASA used the Hubble and James Webb Space Telescopes to photograph the event. DART had hit its target. Now it was time to measure the results. The goal was to see whether Dimorphos had changed its orbit. If the time it takes to orbit Didymos got shorter, that would mean it had moved into a tighter orbit. And if that happened, the mission would be considered a success. Sure enough, on October 11th, 2022, just 2 weeks after the impact, NASA officially confirmed the mission was successful.
And so today, NASA confirms that DART successfully changed the targeted asteroid's trajectory.
Dimorphos's orbit had shortened by 32 minutes. That meant it had moved about 72 feet closer to Didymos. With that confirmed, the next step is to study the impact in detail. We want to compare our predictions with what actually happened. This will help us better understand how momentum is transferred during an inelastic collision with material ejection, and how impact craters are formed, something common across planetary bodies. The shape and size of the crater on Dimorphos will give us clues about its composition and behavior, which is key to understanding the origins of the solar system, and even Earth itself. But that kind of data can't be collected from Earth. We need to go back. That's the purpose of Hera, a mission by the European Space Agency, ESA. They launched a spacecraft in 2024, which will arrive at Dimorphos in 2026 to analyze the aftermath of the DART impact. NASA concluded the experiment was a success. Dimorphos's orbit changed, but the big question is, would that change be enough to save us if a truly dangerous asteroid was headed our way? Or was it just a minor shift that wouldn't prevent disaster? With a cost of $325 million, NASA's DART mission ended up being essentially an expensive, controlled impact experiment. Let's be honest, we still don't have the tech to deal with truly massive asteroids. As a general rule, the bigger the asteroid, the less frequently it hits. But that doesn't mean it won't happen. The only thing we don't know is when. Would we get an early warning? And if we did, would it even matter? Thank you for making it to the end of this video. If you enjoyed it, don't forget to subscribe and give it a like. On another note, if space fascinates you like it does me, I invite you to visit our website, where you can discover a collection of fascinating and authentic images of the universe, carefully selected and transformed into fine art prints of the highest quality, available framed or unframed. And the best part, shipping is completely free worldwide. Plus, with your purchase, you'll be supporting the growth of our channel, something we truly appreciate. I've left the link in the description. Make sure to check it out. See you in the next video.